The topic is finding an equation of a tangent plane, of course to a surface. So let's do the first example. Find an equation of a tangent plane to the surface z equals square root of xy at the point 1, 1. So let's look at the definition. The equation of a tangent plane at AB to the surface z equal f of xy is z equal, let me write it down, z equal f of AB plus fx of AB times x minus a plus fy of AB times y minus b. So in our case, a happens to be 1 and b happens to be 1. So the z should be f of 1, 1 plus partial derivative with respect to x of 1, 1 times x minus a is 1 plus partial with respect to y of 1, 1, and then y minus b happens to be 1. So what's the first thing we need to do? First we need to find f of 1, 1. So what is f of 1, 1? Just plug 1 into x and into y, into the function. So this would be square root of 1 times 1, which is square root of 1, which is just 1. Now before we find partial derivative with x at 1, 1, first we need to find fx at any xy. Now this is going to be partial with respect to x of our function. The easiest way to do this, I'm going to rewrite x and y. So we're assuming, what if both were negative? Well, let me rewrite this as xy 1/2 just to be safe. This is going to be equal, again I need to use derivative of un prime is n un minus 1 u prime. So this is going to be equal 1/2 xy 1/2 minus 1 is negative 1/2 times derivative of the inside means partial with respect to x of the inside. Now this is going to be equal 1/2 xy negative 1/2. Since y is considered a constant, then this is going to be equal y. So let me just rewrite f of x xy. This is going to be y for the numerator, then 2. So move xy negative 1/2 to the denominator, becomes 1/2, so it's square root of xy. Alright, now this means what? This means partial x at 1, 1. All we need to do, plug in 1 for y and 1 for x. 1 times 1. So this is just 1/2. Alright, now, so far we've done that. Next we need to do fy, partial with respect to y, y1. So again, fy of any xy should be equal partial with respect to y of square root of xy. Actually, everything will be the same. The x becomes y and the y becomes x. Am I right? So let's look at this. So the y becomes x and the x becomes y. So this is it. Now this means partial with respect to x at 1, 1 will be equal 1/2 times 1 times 1, which is also 1/2. Now let's write the equation. Z equal f of 1, 1 we found out to be 1, so it's 1 plus partial derivative of x at 1, 1, or this one at 1, 1 should be just 1/2, and then x minus 1. Same thing, partial with respect to y of 1, 1 is right here, 1/2, and then y minus 1. Now all we have to do is distribute, so 1 plus 1/2 x minus 1/2 plus 1/2 y minus 1/2. This means the equation is z equal 1 minus 1/2 minus 1/2 is 1. 1 minus 1 is 0. So this will be 1/2 x plus 1/2 y. And that would be the answer, the equation of the tangent line at 1, 1. So let's do the second example. Second example is the same thing. Now our point is 4, 1. So the equation will be z equal f of our point 4, 1 plus partial derivative with respect to x at 4, 1 times x minus a, which is, remember, this is my a and this is my b. X minus 4 plus partial derivative with respect to y at the point 4, 1, y minus b, which is 1. So again, we're going to do the same thing. We need to find f of 4, 1. So plug in 4 for x and plug in 1 for y. So this will be 4 ln of 1 f of 4, 1. Yeah. So that would be just 4 times ln of 1 is 0, so that would be 0. Now we need to do partial derivative with respect to x. So fx of any xy is the same thing as partial with respect to x of our function, x ln of y. Now since we take in derivative with respect to y, so ln of y is considered a constant, take it outside. So partial with respect to x of x, which is 1, so this is just going to be ln of y. Now this means partial with respect to x at 4, 1 is equal, our y happens to be 1, is equal ln of 1, which is 0. So what else? Now next thing, we need to find partial derivative with respect to y at 4, 1. So again, partial with respect to y at any xy is equal partial with respect to y of our function x ln y. Now x is constant, take it outside, so x partial with respect to y of ln y, which is x times derivative of ln of y is 1 over y, so this is going to be x over y. Now partial with respect to y at the point 4, 1, plug in 4 for x, plug in 1 for y, it's going to be equal 4. So far we got 0, we got 0, and then we got 4 here. What's next? That's it. Now all we need to do, plug in. So our equation will be z equal f of 4, 1, 0 is 0. Fx of 4, 1, we just calculated to be also 0. And fy at 4, 1, calculated to be 4. So the equation is z equal, I'm going to distribute, so 4y minus 4. That's, remember, 0 times anything will go to 0, will go to 0. And that's it for these examples.